For our MLOps project, I have created a crop recommendation and MLOps pipeline system leveraging AI, Airflow, MariaDB, and other tools. Beginning from uh, let's begin from this. Okay, so this is our DAG file, Airflow DAG file, and Airflow DAG file, and we have started from Redis connection with host of this and port number this, and at first we store the inside our Redis, and from there we load from the Redis, and after which we go for reading the data from our crop database and selecting all the tables from crop recommendation table, and then after we go validation, and for validation we have used great expectation uh, to validate, and in the later we write the that crop database data again and make a duplicate so that it can be used for backup, and after which we go for cleaning the data, and before this step we load in our data from Redis with key crop raw, and we go further on different kind of cleaning techniques, winterization and other techniques that we have implemented. After that we go for encoding and scaling, and for in scaling we have used standard scaler, level encoding, level encoder, and all the data are stored to Redis again with key value, dictionary value. So we have also used our Redis connection to share the label encoder and uh, scaler to dump inside the Redis connection, and after which we go for hyperparameter tuning, in which we have used, I have used objective trial of Optuna, uh, which goes for these parameters. I have trained on these parameters. So this is the our DAC file. So to implement this DAC file, we go and start our MLflow server while training and evaluating. In this step only, we start our MLflow server, and all the data from this are artifacts and other data are loaded inside our MLflow backend URL, MLflow DB with the artifact root of ML runs, which I have set, and the model name that I have written is stacking model training. Later, we register our model inside a production stage with model name crop recommender, and we also generate our confusion matrix and other evaluation matrix, training accuracy, testing accuracy to determine. So let's see how we have defined our DAG. So with DAG, our DAG name we have defined M crop recommendation ML, and to run this whole Airflow, we have also implemented a bash operator with task ID of activate conda environment. To activate this, we have set our conda environment. So we must activate this first, and the bash command is like this to activate. And secondly, we start our Docker containers, which are MCS container for MariaDB and Redis store for Redis for our in-memory data. And later we check whether our MariaDB connection is successful or not with this command and execute it and see. And we have defined all these tasks Python operator from above, and this is our how DAG airflow graph looks like. And let's see how it works with one command, how we can start our airflow server. So this is our airflow start.sh file where we have set the conda sh environment and the environment activation print. So to activate, we have to first airflow web server, activate the web server and scheduler, and airflow dag will trigger our crop recommendation ml pipeline. Let's see how it works. So as you can see, I have already ready that after applying this whole command, airflow bash command, the airflow is triggered, and and this is the run id, dag run id, which says it's a manual, as we can have said from started from this. Now let's see our airflow. This is our airflow and it has already successfully run. So I have successfully run this airflow. After making this dag and airflow, we start our MLflow server. To start our MLflow server, we write a command of this. So before starting, we activate our conda environment, and with this command our MLflow server gets started, and inside this https we can see our MLflow server, which looks like this. So this is our where our models and experiments get inserted, and our latest model was trained. With run id 8 hours ago, and these are the parameters after training that get inside our MLflow, and the metrics are training and testing accuracy. And our model about our versioning. So this is our 21st version after a lot of iteration, which get staged to our production, and from here we can deploy with our fast API. So inside our fast API, it looks like this. So there are a lot of metrics, as you can see. So we have get endpoint, 3 get endpoint and 3 post endpoint. So each of these endpoint has different roles. Testing with our metrics endpoint. Let's see what we get. So inside this we get a lot of details about our metrics. These are our predicted crop types that we get from this. Now, second, while testing the predict post metrics, let's see will this will work or not. As we have said, it must work. Let's get some parameter. So it has successfully predicted that the crop type is chickpea with confidence level of 99 0.99.4 and probabilities and all other probabilities, and this is our version 9. So in the same way, other metrics are set. So to see our version, model version, model version, we can see all details of model and the feature samples, etc. And about our status. Let's go from here and see our actual code inside our fast API app.final API. So the code looks like this. So we set up logging, and these are our Prometheus metrics in that we get all the metrics from fast API prediction, and we'll discuss about this later. And feature diff metrics. Uh, so this is our post predict, and this is for model version drift status update our reference. That means for reference for drift detection, we can set our validation score. Let's try it out, and let's set 0.95, and it gets executed. Okay, now for our model monitoring and drift detection, we are using Prometheus. So inside our Prometheus, we can query different types of uh, crop prediction total. So now let's see our graph. This is our graph till now. This is our stack view, and the same in the same way our alert mechanism also works. So if there is high prediction latency, it gets trigger and firing. So and about Grafana. So inside Grafana, we in the data source that we get from is our Prometheus. This is our default as we have set. So and we have two different dashboard for our metrics. So this let's see last one our last 5 minute data. This was the last 5 minutes ago, and we can see a lot of feature drift and other kind of data is being shown here in our Grafana dashboard. And another is HTTPS error rate, request rate, and request duration. All data are shown here. And if any detection is seen of drift in our alert manager, we get a notification of email and email notification of this kind of critical drift score. Let's test our testing. So this is our script that is simulated to test our drift and other kind of detection. It will make a lot of prediction, and later we will get the result. Let's this finish this first. So it's saying this is just for testing if our drift detection is working or not. So let's test another. So it's sending out prediction. So as you can see, out of all tests, what are the testing that we have done? We that is API testing and prediction, and then after drift generated, and then after testing our webhook that we have set for our alert and retraining mechanism. As we can see, we have already seen their success rate of 100%. So if this system is working, our DAG must be triggered, and we must get a report of evidently, and inside our Prometheus and Grafana we must see there should be alert and fire. So let's see our DAG is triggered or not. Let's see. Okay, our DAG is triggered, and inside our Prometheus, let's refresh first. So let's wait because it must be firing. So we can see it's hour 8 hour ago because it will take some time to send us. So for now, mm, let's go and see. And our alert manager is working. No alerts are found. Okay, so this is our drift detection evidently result. So for this, let's for this time let's talk about our file I have set. Okay, we have drift monitoring system. So let's talk about matrix calculation. So inside our matrix calculation, we already have triggered our DAG file because we have a retraining mechanism. If there is drift detected, the DAG will be automatically triggered. And another mechanism is there of manual override, which you can do by getting the email of alert. So the alert email will take some time, I think. Okay, okay. This is our 8 hours ago. This will work because the DAG has been already triggered. I have not triggered the DAG. And let's talk about calculating our drift matrix. So reference data, we have set our numerical CSV file from our training data. So we save the matrix and load the matrix and get the latest matrix. And in our reference data, we can update our reference data uh, and save the reference data and update and compare. So and inside our monitoring, we have different kind of monitoring system. Drift monitor, and we calculate our drift. And the after making prediction, the Prometheus matrix gets automatically updated. All the different kind of matrices inside our version manager. So this is our dashboard, Grafana dashboard that we have seen earlier, and this is the code. Let's see. Okay, so this is our latest. Oh my god. Okay, we have got our alert just now. Let's see what was the alert. It was the alert of low prediction rate. This is the low prediction rate, and this should be shown inside our Prometheus. Let's refresh this first. Okay, okay, it's working. Okay, and it's the same because our Grafana gets the metrics from scraping from our Prometheus. So this is the whole system that works like this. This is just a simulation, and we can scale this for a report. So scrape interval for our Prometheus is 5 seconds and timeout for 3 seconds that I have set. Okay, this is our machine go for clean data. This is our Docker Compose YML file for Grafana Prometheus. Thank you.